Welcome to another video of a HackerRank problem. And today we'll be solving the diagonal difference HackerRank problem in this video. So before we go any further, let's go over the basic premise of this particular problem. We have a matrix of a 3 by 3 matrix, right? Let me bring up out a pen here, right? So this here is a 3 by 3 matrix, right? So we have a 3 by 3 matrix, right? And this 3 by 3 matrix looks like something as you can see on the screen above. So, and we need to basically ultimately do calculate a diagonal difference. So we need to sum this one, this 5, and this 9 first, and the sum of these values need to be stored, right? And then we need to sum this value here, the 5 here, and the 9 here to find and calculate that value as well. Once we have these two values, these diagonal values here and here, we calculate the difference between them. Let's be a little more specific on this. So first, these matrices, they're they they're two-dimensional matrices that we're talking about here, right? So in this two-dimensional matrix, 2D matrix, how do we uh, how do we identify the places of each of these individual elements? Let's go over that as well as we are going over this problem. That is a challenging thing to go over. So in this two-dimensional matrix, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 here, right? So in this two-dimensional matrix, the one here in this position, how do we find this position, right? So the one in this particular position is in row 0 and it's column 0, right? So this particular portion can be accessed through the code, through the syntax ARR, which is the name of the matrix variable, and then we have two brackets here. First one for row, second one, first one for column, first one for row, second one for column, right? That is how you need to remember these matrices work, right? So that's how we access this. If we want to access number 2 here, then what we do simply here in this case would be, to change this 0 to 1, and then we can change this to 2 to access number 3 over here, right? Simple enough. If we go to row 2 here in this particular position, we can access those values by changing the first matrix value. So it would be ARR 1 and then 0, 1, 2, 3 to access this value 0, to access this value 1, to access this value 3, right? Similarly, if we go to this row, right, this one would be changed to 2, and again 0 to access this value, 1 to access this value, and 2 to access this value. That's how you access these values within this matrix. Let's clear this portion up a little bit so we have a little more clear screen as we go about solving, explaining this problem. This problem. Let me actually just delete these two things here. This, this, and this. Right? Get our pen back. So now that we understand exactly what how we access these different components in this matrix, what we need to do is first calculate the sum of these three values in this diagonal, right? That's our primary diagonal sum, PDS basically, right? That would be the PDS. Similarly, this value here. Similarly, we need to calculate a secondary diagonal sum, which is of this portion here, right? And this one becomes R. This one becomes here our secondary diagonal sum. Once we have these two values here, what we need to do to solve this question, we need to deduct from PDS the primary diagonal sum, the secondary diagonal sum. and the value that we get needs is our particular answer for this problem. So that is basically how you solve this particular diagonal difference problem of HackerRank, right? So that now that we understand this, how do we, how do we solve this problem? How do we code this out basically, right? So again, like as we discussed, there are three things we need to do. We need to calculate the sum of the primary diagonal. We need to find the sum of secondary diagonal, and then the absolute difference. So another aspect I think I forgot to mention here, this needs to be an absolute value. And two bars that I'm adding, this is a mathematical symbol detecting absolute values, right? So for this particular value, there's an absolute value here, right? So for this, we need to find whatever the difference might be, it needs to be an absolute difference. So potentially what absolute difference means, let's, get this clarified as we're going to solve this question. 7 minus 3 equals to 4. That's simple enough, right? And absolute, if we do an absolute value of this, the answer is still equal to 4. But if we do, if we have a value, let's say, I'm drawing this error to reflect this is also an absolute value. So if we have a value which is 3 minus 7, right, that equals to minus 4, right? That's what the value is. But if it's still covered in the absolute bars, but when we convert this to absolute value by applying the absolute operator, this value should be 4 again. So this is what we mean by an absolute. Any negative value in the subtraction process would be converted back to a positive value. So with that out of the way, let's start coding our problem basically. So first thing we need to do is to basically understand the length of our array and set up the sum variables, right? So let's set that up. So I'm going to the rank, coding environment. Let me write down the code to tell what we're going to do. So first thing is the length of the array. Then the sum of the primary diagonal or PDS. And then the secondary sum, basically. So we have declared all the variables and the sums. We're keeping them 0 because right now we haven't done any calculations. Then to actually do the calculations, we need to do a simple for loop, right? And basically uh, set that up, right? And basically find the primary sum of the primary diagonal, basically, and the secondary diagonal. There's going to be a slight difference in how we're going to do both of them, right? So it's not going to be a nested for loop, right? I'm just writing the code out so we can start this. So first we're going to deal with the primary sum, and both of them are going to be dealt here, right? So we're going to add this. We're going to add ARRII. So if the value of this is 0, it's going to be 0. The value of this is going to be 1. Both of these are going to be 1. If the value of this is going to be 2, which is the length of the entire array, it's going to be 2. So how does this reflect here? So if we just simply add comments here. So basically, these are the versions of the array that you're going to see here. Rather than that, let me just go over the whiteboard and explain this particular thing. So let's go to a blank space here. Let's open our pen. So we have a for loop here, right? A simple for loop. What is the for loop here doing? So the for loop is rotating over the length of the entire array, which is in this case, length equals to 2, which length is 3, right? That's our range of this particular array. That's the length we have. But uh, again, it's a 0 index, so we're going to work from that perspective in this problem, right? So based on that, the first is going to be 0, right? If the range is 3, so the second I is going to be 1, and the third I is going to be 2, right? And we don't have a nested loop, so if we have a variable like ARR, I and I in this particular problem, if we have we're adding this variable into the sum, what it would result in is A R R. Let me just make this a little correct. 1 1. Sorry, I think a 0 comes first, so let me correct that. AR 0 0, and the last would be A R R 2 2. If you focus back onto the diagonal, this is the primary diagonal that we identify. 0 0 1 1 2 2 is the primary diagonal. If you go back here, this one is 0 0, this one is 1 1, this one is 2 2, right? So in this simple way, within this loop, usually we were for a two-dimensional array, we'll create a nested loop to handle the second integer. But we're not doing that here because with a single loop, we can handle both of them and find the diagonals and make their sum. So this is the sum statement in this particular loop. This loop would sum these three values. So that's why we're using the syntactic sugar of plus equal to on ith value in the loop as seen above. So that way we'll calculate the primary sum, right? Similarly, we'll calculate the secondary sum as well, but it's going to be slightly different. We're going to make a few changes to the value there so that we are able to actually identify that particular sum here, right? So in the secondary diagonal, the first I is going to be the same, right? That's fine, right? That should be the same as well. In the second one, what we do is we deduct our value of I, and then we deduct 1 from this. How would that work, right? So the way that would work is the first array is going to be 0, right? So let's go over here. In this case, the for loop, the first value for us here would be 0 easily, right? And the second value for us would be uh, 0 is the value, so we only have n minus 1 left, right? N minus 1 is the length of the array minus 1, right? Length of the array is 3 minus 2. This should be 2. This value should become 2, right? So we add this to another value. We open brackets here. Again, this would become 1 in the second iteration, and this would become 1 minus 1, 0, so the value of n, right? That would be the second value. Oh, I don't think that should be the case. Give me a second. I think I'm making a slight error in the mathematics here. So yeah, so it would be n minus 2 here. My bad here, right? This would become n minus 2, right? Which should become negative 2, which is basically 3 minus 2 as 1. So the value of this should ultimately result in 1, right? And the third value here, plus, let me actually do it in the same screen, ARR 2, right? And the third value here should be basically 2 minus, ultimately what we see here, the figure here would be, 2 the result would be basically, I think 0. So it would be 0 here, final result, because it would be n minus 3 here from our calculations. This figure should give us the sum of the secondary diagonal. And that is what we're doing, basically, once we set everything up as needed to. So these two diagonals, we have the primary diagonal here, and then we have the secondary diagonal here. Once we have these two diagonals, now we need to find the difference between So primary diagonal minus secondary diagonal absolute value. That's what we need to do. That's the next part of the code that we need to code, right? Out of this for loop. Oh, I think we brought that correctly. So we get out of the for loop, go below, and now we calculate the difference. That's the comment that we need to add, and that's what we need to do. So return the absolute value of the difference between them. So we write the return statement. Then we use the ABS, which is an absolute value function. You add that, and within that, we deduct primary dsum from primary dsum, secondary dsum, right? And if we run this particular code, our problem should be solved. Yep, and that was solved, and that is how you solve the the diagonal difference problem in HackerRank. And again, like if you have any value, if you got any value from this video, please like and subscribe. And if you have any questions on any problem or any concept that you want to clear in programming, please let us know in the comments below so we can focus on that next. So with that, we're going to wrap this video up, and we'll see you in our next video. Thank you.